Hello, everyone. You're welcome to the third installment of my series on automating the dev process and the deployment process of an application hosted on Kubernetes, Docker applications hosted on Kubernetes. So far, we've been able to use PowerShell to create Azure resources that will host our cluster, handle our cluster and container registries. We've also been able to put a web application that we compiled with Docker and deploy to Kubernetes under source control on Azure DevOps repo. We've also been able to create an automated CI/CD pipeline to automate the building of these application and the pushing of the image into the container registry on Azure, and also the deployment of this container into Kubernetes. So on this installment, what we want to do is to further extend our CI/CD pipeline to go all the way apart, not only to deploy into dev, but to go all the way into QA, staging, and prod. Not only that, we also want to install gates on the QA, staging, and prod deployment phases as well. Then, once we have that done, we are also going to install pull request triggers to ensure that no developer just chucks in code into the dev branch that will go all the way to production without anyone seeing that code. And the beauty of the pull request trigger here, I'll show it to you once we have it in place on the dev branch. Then also we're going to implement a link to work items. No one is just going to be able to check code in without linking it to a work item, and that's going to help. It's going to help our tagging, and it's going to help our audit in tracing changes back to where it started from. Okay, so let's start with our activities. So the first thing I want to do is to extend our pipeline. We want to extend our pipeline to not only deploy into the dev namespace on Kubernetes, but to also deploy all the way to QA, staging, and prod. So there's no other place to start from than the pipeline. So we're going to repo, we're on the develop branch, that's the right branch, and we're going to go into our YAML, and then let's start editing. Now, this is the way it works. Now, after the build stage, it's going to run a test here, it's going to run a condition here, and is only ever going to execute this if it meets this condition, which is that is this build triggered by a pull request or by a direct code check-in. So if it's a direct code check-in, it's not going to come down this way. It's going to go all the way into the dev stage. And this is where the dev build starts. So we've seen this dev build work, the dev deployment rather, work, and we've seen it work on the dev namespace of the Kubernetes cluster. So what we're going to do is we're going to copy these out. We're going to copy this and plunk it here. So we're going to call this the QA stage. It's pretty much almost a copy and paste job. So this is the QA stage. But this time around, the QA stage is not going to depend on build. It's going to depend on the success of the deploy dev stage. So over here depends on deploy dev stage. And then we're going to rename this QA, QA, QA. And then we're going to turn this into QA dot QA. The environment dot the namespace. And there we go, and that's it. So we're going to deploy the copy out the next one, do the next one, which will be copy which will be staging. So that's deploy QA stage. And now this one is staging. 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 And staging. And the deploy staging stage is going to depend on the QA stage. This is deploy dev stage depending on the build, and the deploy QA stage depends on the dev stage. Sorry, the dev stage, and then the deploy staging stage will depend on the QA stage, the success of the QA stage. And the next one we're going to do the QA stage. We're going to copy this here. And this is going to be the prod stage. So we just copy this one out. Control C. Depends on the staging stage. And this is the prod stage. The prod stage. The prod job. And the prod job. And this is going to be prod dot prod. So we're done. Prod dot prod. So let's commit this into develop. And let's go to our pipeline. Now this is not going to run. I'm sure you know why it's not going to run. If you go into the pipeline, it only includes files that are within the source code subfolders and subfolders. It excludes everything else. So the way to get the build to run, and this time around is going to run all the way from dev to QA to staging and to prod. So the way we can get the build to run is to trigger it manually. So run pipeline, and we're running it against develop. So you can see the shape now of our workflow. So once the build stage is gone, if it's a pull request, it comes this way and it ends this journey here. If it is not a pull request, it's going to come into the dev stage, deploy into the dev namespace of Kubernetes, and once it's done, it goes on to deploy into the QA stage, goes on to deploy into the staging stage, and it goes on to deploy into the prod stage. So let's see what it's doing. So let's have a look at our build so far. It's still building on. So the way we've done is that we've chained these stages to themselves. So there is a dependency on the success of the previous stage. If the previous stage failed, then the whole thing collapses. And that's how pipelines are built. So it's going through the build stage at the moment. So it's going to compile the code and build the image, and then push it into the container registry to hold the image. yet. So yeah, while that is going on, I have a cool feature here, a very cool feature that I want to get going. It's called Slack integration. Have you ever heard of the app, the mobile app called Slack? So is a very cool feature here called Slack integration. Let's see if we can play with that while this is going on. So let's go to this is our project folder here, AKS calculator demo. So if I go into Slack, let me go into Slack here. So if I go into Slack, I can do a subscribe. I can do AZ pipelines, subscribe, and then put the URL of the project. And it's going to subscribe to notifications on the project. And we're going to start getting as added subscriptions to run state change and run stage waiting for approval notifications for pipeline on any in project AKS calculator demo. So you see, a run just succeeded on the deployment dev stage. So you see that's the notification come through. If we move away from Slack, we're going to see the notifications come through on the you see that's one just come through now on the QA stage. So the QA stage has been deployed, or QA stage is running, rather started running, so it's letting us know about it. So you see the dev stage is developed now. Is deployed onto Kubernetes. Let's have a look. It's the same IP address. If you remember this IP address, 52.157.109.36. 109.36. Yeah, and that loads correctly. And if we go to our Postman, let's go to calc dev. So you see it works. If we go to the runner on dev, calc dev, all 6 tests passed. So that's good. Then let's come over to see how far we've gone. See, a notification just came in. QA stage deploy succeeded. So let's see if we can grab the IP address for the QA and plunk it in. So this is the IP address, 52. So deploy stage running, staging stage running. So this is the IP address for the QA stage. See, the staging stage is running. So let's go make use of this IP address. So it's loading up. Apparently that's his first time, so it takes a little bit, a few more seconds to load up the page. There you go. So it's done. So we can now go to Slack. When we get to Slack, we want to put that in the QA section, calc QA. So put the IP address here. So that's the calc QA. So let's go straight to the runner. Let's waste no time. So we go straight to the runner. We put in the QA stage, calc QA, run AKS calculator, all 6 tests passed. So our QA deployment is correct, verified. So let's go. Okay, so staging process 2 has succeeded. So let's pick up the IP address for the staging stage for Kubernetes. So what's the IP address? 52.137.38.84. So let's get it started here. Let's plunk it here. So you see, these are all separate deployments. There's a separate dev deployment, a separate QA deployment, a separate staging deployment, and we're going to see a separate prod development. See, it's working. And let's go to Postman. Postman is the fastest way to test these things. So let's go to the staging stage. Do we have a staging stage? Oh, we don't. Oh, okay, so this is what we're going to do. Let's go to calc dev and let's copy it. Calc dev and copy it. Staging. Calc dev copy. So that will be calc staging. And then we put the IP address here. So the entire build is succeeded all the way from dev to prod. So we've put in calc staging. So let's run the tests for calc staging. Calc staging, and then let's go here. Uh-oh, 2 failed, 0 passed. All right, so let's go to our configuration again and see what happened. So we're looking for calc staging, yeah. And we need to put in, oh, okay, I found out what's going on, this one. So that's it. Let's go to runner for the calc staging. So calc staging, and that should give us all passed. So all good. And then the last one will be the prod. The prod stage. So let's go get, so it's all succeeded now. So effectively, we can plunk in a change to the code, and it's going to deploy, as long as it's compiled correctly, it's going to deploy all the way from dev to QA to staging to prod. And that is such a beauty. That is such a beauty. So this is the IP address for the prod. So let's grab that and complete our testing. Okay, let's load it first through the browser and make sure that the web application is started. Yeah, so it's come up very quick. And then let's go to Postman and put the IP address in calc prod. Yeah, we need it in calc prod. Yeah, so that's it here. Yeah, calc prod, and that's it there. So let's go to the runner and select the test suite, select calc prod, the production. All 6 passed. So we've been able to complete our end-to-end build and deployment pipeline, all the way from dev to prod. All the way from dev to prod. So this is such a beauty. So just in case you missed it out, this is what we're going to do. So this is the develop branch. So let's go to develop branch, git pull. So we're up to date on develop branch. But in the meantime, let's even have a look at our kubectl namespace, get namespace. So you can see now the dev namespace, prod, QA, and staging. So let's have a look at some of these things. So let's go to staging. So you can see the deployment 6 minutes ago. Let's go to prod. You can see the deployment about 4 minutes 58 seconds ago. Let's go to QA. You can see 8 minutes ago. And let's go to dev. can see 165 minutes ago. That was the first one we did on video too. So you see all the namespaces. So these applications are running on separate namespaces, separate instances, which is a beauty. Let's do get pods, and we can see all this running in their separate spaces. So you get pods dev, get pods QA, get pods staging. You can see that they're all different instances, and get prod. You see that? You see the timings, and you see that they're all different pods. So we have a total of 8 pods running: dev, QA, staging, and prod. Let's check out service. So we have, let's start all the way from dev. So that's our dev service. You can see 166 minutes ago. This is our QA service 9 minutes ago. This is our staging service 7 minutes 57 seconds ago. And this is our prod service 6 minutes ago. You see that? You see that the external IP addresses are different. They're all different. So these are separately deployed. None of them is impinging on each other. So we have dev namespace, QA namespace, staging namespace, and prod namespace. This is such a joy. So we've been able to build that and to test that. But just in case, just for us to ascertain that this workflow is entirely correct and this is going to trigger the build, let's add a change to the source code. So this is an artificial change to the source code now. So let's save it. So we have a change there. And then the next thing we want to do is to stage it, stage all changes, and then commit staged changes. Let's call it small change that should trigger a build. So this is the developer checking his changes in. So it's committed and it's pushed. So I mean, we assume that you've done all your small testing on your on your workstation, on your work surface, and then you've checked in the code into the repository. So let's see what happens over here. You see, the build has been triggered and Slack has come back. And this is very cool because I'm getting these notifications on my phone as well. So which is a very cool thing. So you can see the circles here. So this is the build, and this is going to be the pull request stage, which is not going to run. And this is going to be the dev stage, the QA stage, the staging stage, and the prod stage. And it's going to run quick at this time because the services and the namespaces have all been created on the Kubernetes cluster. So the longest stage for now is going to be the longest stage is going to be the build stage. So this is the build stage. It's not going to come through here because it's not a pull request. It's going to come through this way on the dev stage, on the QA stage, on the staging stage, and then right onto the prod stage. So this is such a joy. This is such a joy. This is such a joy. Now, while that is going on, let's keep ourselves busy because of our time. What we're going to do now is we're going to install gates. We're going to install gates on the dev deployment, the QA deployment, the staging deployment, and the prod deployment. And the way we do that is that we go into the environment. So we go into the dev environment here, and we do approval and checks. So we add our first approval. So I'll add myself. So check that all the changes are going in. So allow approvers to approve their own runs, which is useful for me because I'm the only one today on this project. So let's create. So we've put in an approval and check on the dev, and then we do the same thing for the QA. We do the same thing for the QA, and let's see, approval and checks. So we add the approval to it, add myself. Yeah, check that there are no bugs. And then we'll create. You see the Slack notifications are coming through. So that's QA. And then let's go to staging. So for staging, we're going to do the same thing. Add an approval and check. Add myself to it. Check that the user acceptance criteria. This is a note to our QA guys. Have been implemented, just for the fun of it. So let's create. And then we're going to go to the prod stage. So the users, or more like the business users, are going to be the ones to approve a deployment into the prod stage. So all good to go. So this, and then we create. So that's all done now. So we've been able to add those gates. So let's go to the pipelines and see how far we've gone. Okay, so it's all completed. You can see now everything is all green. So everything is all green, and we can always test any of the stages. Now, what we don't want is a situation where a code monkey comes in, checks in some code here, and it goes all the way to dev, all the way to QA, all the way to staging, and all the way to live without anyone seeing what he has done. So we definitely have to put in some restrictions, and that's the reason why we have put in these gates. That's the reason why we have put in these gates. Now, the next thing we want to do is to add in a facility for a pull request trigger. Now, this is a very interesting one. The pull request trigger is a very interesting one, and you're really going to enjoy this one. So let's come over to the branch. Now, the way we implement that is by working on the branch. So we're going to go to the branch, and all the while we've been doing all our stuff on the develop branch. So we'll come over here and set up what we call a branch policy. Now, with the branch policy, we're going to check for linked work items. So, which is we require a linked work item. And also we're going to now add this build policy here, build pipeline on this pipeline, and trigger automatic whenever the source branch is updated, and build must succeed. The requirement is that the build must succeed in order to complete pull request. Now, let me tell you the beauty of this. Now, almost everywhere, of every place where I've worked, what tends to happen is that when you do a code change and you ask for a pull request and you submit a pull request, your dev manager is going to look at the actual source code that you changed and make sure that, okay, it adheres to the coding standards and all the rest. But your dev manager hardly sees the application running. So you can have a good code change, but you've introduced a bug or regression into the application, and your dev manager is never going to know because he never saw the application run by himself. He never tested the application by himself. And in some cases, where the dev manager feels that, oh, okay, I need to see this code run, he's going to have to come over to your own machine, to your own PC, to see what you have done and to see the code run. And still that doesn't cut it. And I'll tell you why. It's possible for the code to run properly because your own development environment is different from the environment on the server. So it's possible for it to run perfectly on your machine and not run perfectly on the build server or run perfectly in a proper runtime environment. So what this pull request facility brings to the table is that when you submit a pull request, it will take your code changes and put them on top of the branch that you are merging to and do a build. And it will not only do a build, it would also deploy the build to a brand new namespace where your manager can actually have a look and see the code run and be sure that you've done the right thing before he puts his approval in. And that's what we're going to test now. So let's see, pull request trigger on dev. Because almost every place where I've worked, the manager, the dev manager or your colleague has no way of checking that you've done the right thing or the application even works, has no way. So pull request trigger on dev required, no filter, and that's enabled. Let's see if we were to put a filter. So filter is set, policy will only apply when files which match the filter are changed. Leaving this means that the policy will always apply. Yeah, that's fair enough. Okay, that the policy will always apply. So, and also we're going to be checking for linked work items. So right now, we have a okay stay. Oh, we need to save the changes actually. So we've saved this build policy on the dev branch. So it means that the party is over. We cannot just check stuff in now. That is just going to go all the way and all the way. So everything is going to be locked down now. So let's see something here. Let's create a new work item and let's create a new task. So we have a new task for our code monkey, and this is the task. We need to implement a subtract functionality. Subtract functionality to the application. So assign it to the only code monkey on site. Let's just copy this, whack it into the description and iteration. Let's call it iteration 1 and let's save it. So if we go to the board, we should see the work item. Okay, let's go to the backlog actually is where we should have been going. Wow, this thing takes a while. Okay, so let's turn this to active, means that we've started working on it. So it's active. So the next thing we're going to do is we're going to go to the repo. Since we're here, let's go to the branch on the develop branch and let's create a new branch. Let's create a new branch. Let's call it the subtract feature. We're going to base it on develop, and we're going to select the task here, task 79, and let's do a create. So that's the subtract feature. And then let's go to let's come over here, demo, git fetch, wrong spelling. Okay, git checkout subtract feature. So we have some code changes to do. We've gotten a code monkey to give us a subtract feature, and we're not, because of our time, we're not going to stay too long on that. So let's edit and uncomment this line of code. So you see, subtract input 1, input 2, input 1, input 2, and we're doing a minus here. And that's all there is to do. So we have a subtract here. So let's save this. So imagine we're doing this locally. We're not just going to plunk it into source control. What we're going to do is we're going to build it. So we can come over to our AZCLI. No, not this one. Okay. Yeah, this one. So we can just do this here. Control C. Because we've made the change, so we want to test it locally. Oh no, we need to do a proper build. Unable to prepare context, unable to sim links. Oh, okay, we're in the wrong folder actually, sorry. Okay, so this is the top folder here. Let's do an ls. Oh, okay, couldn't find it. So let's go into the source folder, and then let's go into AKS calculator. So yeah, this is where we have the Docker file. Okay. So if we just come here and then just do a run line in terminal. So it's gonna, so we've made this change. Imagine that we have made this change. So we're gonna do a build now. Oh, it says the container is in use. Oh, by something we've done before. Okay. So what we're going to do is let's go into the dashboard. So let's go into the dashboard, stop this and remove this, stop this and remove this, stop this and remove this. So they're all gone now. So let's repeat this. Okay, so it's up and running, 8081, 8082 and 8083. So let's go to our browser and put in localhost 8081. So 8081 is running. Now we have two functions. Can you see? We have a subtract function. Let's try it out. So this is on our local. We have not yet gone into Azure DevOps. So we're testing it locally. 5 minus 6 is -1. So which is good. Let's apply a dodgy value here. 5 and RR. Input string was not in a correct format, which is correct. So we've done our changes locally. We've tested locally. It's time to introduce our changes to source control. So we come over here. And we stage all changes. And then we're going to commit staged. And let's put in something meaningful. So let's look for the, where's the board again? Yeah, so this is task ID task 79, implementing a subtract functionality, task 79. So let's key in task 79 and copy and paste that, implement a subtract functionality, or let's say just say code to implement a subtract functionality. And then that's committed. And then that is pushed. So we've pushed our changes to our feature branch, subtract feature. And let's see. Let's go to the repo. Let's look at our commits. Subtract feature just now. So let's look at subtract feature. So you see, you updated subtract feature just now. Create a pull request. See, code to implement a subtract functionality. So let's create a pull request, because there is no way we're going to be able to get that into develop. So we want to merge these into develop, and you can see that it's populated the title of this pull request for us nicely. He's also added the task, the work item, to the pull request. And then I can choose the reviewer or a bunch of reviewers. And then under the pull request, you can see the changes that we have made here. So, nicely to compare side-by-side diff. And then you can go ahead and create a pull request. Now, this is where the beauty starts. Now, the policy is that it should check that a work item is linked, and it should do a pull request build on those changes. So it's already checked that the work item is linked, and it's gone off to start a build. And this build is going to comprise your changes and the current dev branch to see the impact of your changes on the dev branch. So let's go to the pipelines. You see it's chugging away now. And also you can see that we have a build stage and it's going on. So fingers crossed we should get past, we're not going to go into the dev stage, we're going to go into the pull request stage. And what the pull request stage is going to do is going to use the request number to form a namespace title and create that namespace for us on Kubernetes. And this is such an awesome innovation. I really love this. I really love this. So you see, with a pull request, it means that whoever is reviewing your pull request also has the opportunity to see the impact of your changes on the running application. And that is so cool. That is so cool. So we're going to wait for this to build. And we're going to wait for this. So it's going to push this all the way into... In fact, it's been a while since we saw what was going on Azure. See? So we already have 6 images put in here. The last one was put in at 5:21. And what's the time now? It's 5:39. So let's see. So it's done running now. So you see it's gone over to the deploy pull request branch. See, it's running now. So it's created a new namespace. Namespace 21. That's the name of the namespace. And I'll tell you how we got namespace 21. I'll tell you that later. Oh, okay, it's deployed and it's waiting for the external IP assignment. Okay, let's go to the pull request. I'll tell you where you got that number from. Let's go to the pull request. Can you see pull request number 21? So the next pull request is going to create a namespace for this, and it's just going to keep going on and on. So separate namespaces for separate pull requests going on. We can change it because what I've done, this is a pull request number. So you see, if you go into the pipeline here, so stage pull request succeeded. So if you go into the pipeline here, you see deploy pull request. You see I use the pull request ID. So we can change this into something else. But you see what it means is that it gives us a silo. So each pull request ID has its own silo on the Kubernetes cluster, and we can get rid of these silos as soon as the pull request is approved. So we have a pull request built. Now this is one thing you should note. Let's look for one of these IP addresses. Let's look for one of these IP addresses. kubectl. Let's look for one of our kubectl addresses. Okay, kubectl namespace service namespace. Now, this is the IP address for the QA. 52 da da da. So let's plunk these into the browser. So if you put these into the browser here, so you see that on the QA we have only one function here. But now if you go into, if you grab the IP address, let's go to the pipelines and let's go to the pull request stage. If you grab this IP address and click on it, oh, okay, it didn't let me go on it. So let's see. Oh, okay, I don't think, okay, let's see. Control C. Let's come over here. Let's cut all this out. So this is our pull request build. Can you see? That's the subtract functionality. So whoever is checking your code can have a look at the new functionality and do his own, run his own tests. Let's put 47, 44 minus 47. If it's anything different from -3, then we reject it. So you see, that's -3. So I'm the manager. I think the code monkey has done a good job. So I can go ahead to approve his changes. So I then go to the board, go to pull requests. So I think I'm satisfied. He's made some decent code changes and I can approve it. So approve and then complete. Now, when I do that, something is going to happen. It's going to complete the associated work items after merging, and it's going to delete this branch from the repository. So complete merge. And that's it. So if we go to branches now, subtract feature is gone and is merged into develop. So, and then a build, the proper build has been triggered on develop, which is very cool, So let's go to our pipelines. So you see the build is started. So this time around is going to build and go all the way to deploy the dev and the QA. So that's one thing done. The branches disappeared. And then let's go to the board to look at our work item. You see recently completed. Let's go. So it's automatically closed that work item for us. Did you see that? Implemented subtract functionality and it's closed. And it left us one comment, which is completing full pull request 21 and the associated items. So this is just cool. This is cool. This is automation. I love this. I really love this. So let's look at what's happening on the pipelines and see how far it's gone. Okay, so it's still chugging away at compiling. So how far have you gone? Okay, just 5 out of 20 steps. So let's see this succeed. So right now it's going to go, the first deployment is going to be to the dev environment. Once this deployment is done successfully, then we can close this video and hopefully look forward to a fourth installment. On the fourth installment, we're going to be looking into a microservices architecture and also being able to cater for a proper microservice architecture with what we have on AKS calculator demo, AKS calculator demo service. So we just wait for this build to finish. It's pushing, pushing this into the registry. Oh, there's one other thing that I've not mentioned yet, which is that have you noticed that we're building only once, pushing into the registry, and it is the same image that we're deploying all the way from dev to QA to staging and to prod, which is very nice. Because if we had to do another build, then we're not really sure that what we built the first time is what we're actually taking along. So it's really, really, it's really so cool that it's the same image that gets deployed into dev. If it is approved, it's going to QA. If it is approved on QA, it's going to staging. If it is approved on staging, it is going to live. So let's see. Oh yes, Can you see? You know, we put in a gate the other time on each of these environments. So despite the pull request being done, we also put a gate here. And we can have several reasons for having a gate. It could be that to go into the dev stage, we're expecting 3 tasks to go into it, and only 1 task is ready. So what we can then do is we can fail the build here, we can fail the deploy here, and wait for those tasks to come in and get merged into the dev branch, and then start the build again. But for this one, because of our time, let's review and let's approve it. So let's approve it. Check that all the changes are going in. So that's what the dev manager will do. Make sure that all the changes are going in. 1 check passed. And we can add as many checks as possible, which will make it more interesting. So it's now going to do the deploy into the dev environment. And it's going to be a lot quicker this time because the dev IP address already exists. So it's going to do it a lot quicker, You see, it's all done. Then it's going to go on to the QA stage. So let's go back to the pipelines here. You see the Slack notifications are coming through. You see, so it's waiting for an approval here. So at this point, we want to be sure that it's okay for it to go into the QA stage. So the developer manager and the dev manager can handle this review. Say okay, check that there are no bugs. Everything is gone in. Then approve. So it's deploying into the QA stage, and that's the stage where the QA guys are going to come in and run all their checks and everything. And these are separate namespaces. So this is a separate namespace, the dev namespace. This is deploying into the QA namespace, and they're not impinging on each other at all. They're not impinging on each other at all. So that's the QA job chugging away. So it's been deployed successfully. So let's go to the pipelines and be sure that it's not waiting on us for the next approval. Oh yes, it is for the staging one. So the QA guys are the ones who are going to approve this. Check that user acceptance criteria have been implemented before letting it go to the staging area where the business users are going to do their own checks. So it's running the deployment now on the QA staging. So this is very cool. And this can even be a bit more sleek because if we had used the code editor, it can send emails out, it can send notifications out to ask for these approvals. It can even send Slack messages out to, the message is even here, you see. So what this means is that if you have Slack on your phone, you can use your phone to approve a deployment. So you can be down the pub or down the restaurant and approve a deployment. So the next approval has come. Approval pending for the deploy to prod. So the business users imagine that they're having a meeting somewhere with Boris Johnson, and a notification just comes in on their phone that something needs to be approved, and the guy just click this, approve. Bang. So I've approved these on Slack, and let's see what happens on the build. You see? It's going over to prod. So I've approved the prod deployment right on my Slack. And I could have done that on a phone. I could have done that on an iPad. Slack integration, which is very cool. So you see now the deployment is going on Kubernetes. So we're not going to test all the stages through because of our time. We need to run. What I'm going to do is I'm going to only just look at the very last one, which is the prod one. Yeah, I'm just going to look only at the last one, the prod one. So what's the IP address for the prod? That's this one here. So we just go to the prod here, plunk it here. We should see 2 calls, 2 functions, add and subtract. Yeah, that's your add and subtract. And if we go to your postman, if we go to the postman, we already have IP addresses for the prod. So, but let's see. Calc prod. That's our calc prod. at least for the current, we need to write new tests to cover the subtractions. But meanwhile, this is very good. So today we've been able to achieve a number of things. We've been able to extend our automated build pipeline all the way from the dev environment, the dev namespace. We've been able to extend it. Let's have a look here. We've been able to extend it, dev, QA, staging, and prod. We've also been able to put in approval gates on dev, QA, staging, and prod. And also we've been able to implement some very strict controls on how code can be checked in through the use of pull requests. And also we have a pull request triggers that can trigger a build, a pull request build, and put it right into Kubernetes. Also, there's one more thing I forgot to show you. Let's do kubectl and see where that namespace is. Kubectl get namespaces. Can you see? Namespace 21 created 13 minutes ago. That's where the pull request build went into. So if you do get service namespace 21, you can see the IP address 1380.43.180. That's where the pull request build went into before the approval was given on the pull request. So if you copy this IP address and plunk it into the browser, bang, and that's it. So that was a pull request build with the subtract functionality. So we've been able to do a number of things, which is extend our automated build pipeline to go all the way from the dev branch into the QA branch, into the staging branch, and to the prod branch. We've been able to put in approval gates all the way through from the dev to the prod stage. And we've also been able to enforce two branch policies, which is that you can only merge into develop using a pull request, and you can only merge into develop on the wings of a valid work item. So thanks for watching, and thanks for your patience. Hopefully on the next installment of this playlist, I'm going to be looking into breaking what we have done so far into a bunch of microservices, and that is going to impact our deployment. Again, is going to impact our process, our development process, our CI/CD pipelines, and it's really going to be an interesting one on video 4. Thanks for watching. If you enjoyed watching this video, please give me a like and share it with the developer community in Kubernetes and Docker and in the .NET Core world. Thank you so much, and see you next time. Bye bye.